Hi guys, I'm going to solve the problem for the Olympic diver that we saw in last lecture. So we have a diver who is dropping from a platform that is 10 meters high. And if you remember when we talked about the formulas, there are two different situations that we may encounter when we're talking about vertical throws. One of them is if we are jumping from, let's say, the ground and we're going high, so we're going from the ground and we're going up. That means that at some point we're going to come to a stop, and in that case, our V2 or our final velocity would be 0. In this case is the opposite. So the diver is dropping from a high surface that is 10 meters high, meaning that V1 or his initial velocity would be 0. It is stated in the problem, but it may not be explicitly explained in another problem. And if they are dropping, then you can assume that V1 is 0. Okay? From this, because the diver would be traveling in the vertical line or in the y-axis, that means that the person would have an acceleration of gravity. So an acceleration of 9.81 would be acting on him. So we have this diver here. Let's draw him. And he's standing on a platform that is 10 meters high. Right, that's the floor. And all he's got to do is jump, right? And he's going to have a V1 of 0 meters per second. And the question is asking what his final velocity, or the velocity right before she hits the water, would have. So we want to know V2. We have a distance in the y-axis, right? We also have an acceleration, which is the acceleration of gravity, 9.81 meters per second squared. And let me just do that a little bit cleaner. Oops. Okay, so, sorry. So acceleration equals to gravity, which is negative 9.81 meters per second squared. Okay. So we want to know that, and we also want to know how long did it take. So we want to know the time as well. So the time that it took her to go down. So we're going to go and look at our formulas. And here we see the formula sheet that I posted for you. So we have on the right-hand side, we can see the two different situations. So here, right, and here, these are the two different situations in which we have somebody moving in the y-axis. The first one on the top is in the case of the problem that we have, because we have a diver who is dropping. That means that we know that his initial velocity is 0. So V1 is 0. Therefore, we can use one of these three formulas, okay? Because we know that his V1 is 0. So then what we're going to do is we're going to go through each one of them. So V2, because we want to know V2, is equal to the acceleration times the time. We do have acceleration, but we don't have time. Therefore, moving on to the next one, okay? So then the second one is, okay, so the distance, we have a distance in the y-axis, is equal to half the product of the acceleration times t, or the time squared. We don't have time, but we do have all the other variables. Therefore, we can use this formula so we can find t. And this is how it's going to look like. Okay, so we have the formula here that we just saw. Do we have d? Yes, we have a distance in the y-axis, right? So we have, well, 1.5 is a constant. We have the acceleration of gravity. Now what we want to do, we want to rearrange the formula so we isolate t. So what is that going to look like? So we can sort of consider that this 1/2 is sort of like this, okay? Because the 1/2 is multiplying acceleration and also t squared. So I'm going to do it in steps for those of you who are uncomfortable rearranging formulas. So it will look like 2d equals at squared. And then we can do t squared equals 2d over acceleration. And then we can just change the sides, right? So then it can be time equals to 2d over acceleration. And because we have squared, then it's going to go to the other side, being the square root. So then we can find the time by plugging in the numbers. So we have 2 times 10, right? And then we can divide that by, the whole thing. So 9.81. And then what is that going to be? And this is equals to 1.43 seconds. Okay. We don't have to worry whether the fact that we have a negative acceleration because it is a scalar quantity, so we don't care about whether it is positive or negative. So we know that it took her to drop 1.43 seconds. Now we can go back to our formula, and now we can use either this or this, either one of them. So we can use this one. V2 is going to be equal to A, which is gravity, and then time, which is the one that we just calculated. So now in order for us to be able to calculate the final velocity, we can just substitute, and we're going to have Vy2 is going to be equals to the acceleration of gravity, which is negative, times 1.43 seconds. And that's going to be equal to, sorry, I should have said the units. So this is meters per second squared, right? So if we have this and we multiply it by seconds, we're going to end up with meters per second, right? And the final result is 14. Oops, it's a really ugly 4. But it comes to 14 meters per second. So now we know that the person is going to have a speed a velocity. Oh, and this is negative. A velocity of minus 14 meters per second, and because it is negative, that means it's going to be down. Okay, because we're talking about velocity.